Assalamualaikum, we are from group Ngantuk Network. We're gonna present about resistor network relate to the application of linear algebra. Okay, next, my group members is Muhammad Iqbal bin Zainuddin, Nur Afiqah Fatanah binti Ahmad Fauzi, Muhammad Farizan bin Romzi, and me myself Adili Hasha binti Ahmad Yunis, and lastly Nur Ariana binti Kamarudin. What is resistor network? Resistor network, also known as resistor array, feature multiple resistors connected together in a circuit pattern. They primarily act as a voltage divider, which split the voltage in a circuit to smaller amounts. Next, the purpose of study to find the value of current in the circuit.
Next is from me. So we can see here this is the question that we need to prove. The diagram below consists of 4 circuits. The current in the 4 circuits is denoted by I1, I2, I3 and I4. Using Kirchhoff law and the Gaussian eliminator method, write an equation for each circuit and solve for each current. So I will explain about Kirchhoff law. According to the Kirchhoff voltage law, the voltage around a loop equals the sum of every voltage drop in the same loop for every closed network and equals 0. Put differently, the algebraic sum of every voltage in the loop has to be equal to 0, and this property of Kirchhoff law is called conservation energy. So from the equation, we use the Kirchhoff law to find if the voltage is positive or negative. It can be shown that I4 run through the positive right way in counterclockwise, and the voltage will be positive. And we can see that I3 run through the opposite direction, so the voltage will be negative. So I will pass to the next person.
Next is Gaussian elimination method. In mathematics, Gaussian elimination, also known as row reduction, is an algorithm for solving systems of linear equations. It consists of a sequence of operations performed on the corresponding matrix of coefficients. To perform row reduction on a matrix, one uses a sequence of elementary row operations to modify the matrix until the lower left-hand corner of the matrix is filled with zeros as much as possible.
Okay, next we move to the how to solve this question. So firstly, the first step, we need to change the diagram into the equation, linear equation. But before that, we need to use Kirchhoff law to convert the diagram into the linear equation. So for example, starting with the top right, which is I3 circuit, multiply the resistance by the ends and the sum of the resulting products. Especially consider the resistor label 4 ohm that is part of the circuit of I3 and I4. Notice that current I3 runs through this in a positive counterclockwise direction, and I4 runs through in the opposite negative direction. The product of resistance and M is then for I3 4 in bracket I3 minus I4 equals to 4I3 minus 4I4. Continue in this way for each resistor and set the sum of the products equal to the voltage source to write the equation. So the linear equation from the circuit I3 will be 6I3 plus 2I3 plus 4 in bracket I3 minus I4 plus 4 in bracket I3 minus I2 equal to negative 23. And lastly, the final answer will be negative 4I2 plus 16I3 minus 4I4 equals to negative 23. Next, for the equation for upper left circuit, which is I2, will be 2I2 plus 12I2 plus 4 in bracket I2 minus I3 plus 6 in bracket I2 minus I1 equal to 0. While for the lower right circuit, which is I1, it will be 10I1 plus 6 in bracket I1 minus I2 plus 8 in bracket I1 minus I4 equal to negative 27. And the last one for the lower left circuit, which is I4, it will be 4I4 plus 4 in bracket I4 minus I3 plus 8 in bracket I4 minus I1 equals to 18. And notice that the voltage for the upper right and lower right circuit are negative due to the clockwise direction they indicate from the diagram. So after we get all equation, we need to simplify and rearrange the variable in order we have, which is the final answer will be 24I1 minus 6I2 minus 8I4 equal to negative 27. And for the second circuit, it will be negative 6I1 plus 24I2 minus 4I3 equal to 0. And third one, negative 2I2 plus 16I3 minus 4I4 equal to negative 23. And the last one, the fourth circuit, will be negative 8I1 minus 4I3 plus 16I4 equal to 18. Okay, next, the third step, after we get the linear equation, we need to convert the linear equation to the augmented matrix, and will be same into the diagram, which is 24, negative 6, 0, negative 8, negative 27, negative 6, 24, negative 4, 0, 0, 0, negative 4, 16, negative 4, negative 23, negative 8, 0, negative 4, 16, and 18. So for the fourth step, after we get the augmented matrix, we need to convert the augmented matrix to row and geometric form, which is REM, by using elementary row operation ERO, and solve this matrix by using the Gaussian elimination method. So it implies the linear algebra method in this question. So after we get the augmented matrix, we need to find the leading one. So the first step is row 1 we divide with 1 over 24, and will be 1, negative 1 over 4, 0, negative 1 over 3, and negative 9 over 8. After that, in Gaussian method, we need to alert that below the leading one, we need to be the value need to be 0. So we need to remove all the value below the leading one. So the next step, 6R1 plus R2, and will be 0, 45 over 2, negative 4, negative 2, negative 27 over 4. The next one, we need to remove the value in row 4. So we need to do 8R1 plus R4, and it will be 0, negative 2, negative 4, 40 over 3, and 9. Next step, we move to the row 2, and we need to find second leading one in row 2, column 2. So it will be 2 over 45, R2 will be 0, 1, negative 8 over 45, negative 4 over 45, negative 3 over 10. And next, we do the same thing for the leading one. So below the leading one, we need to get a 0 value. So it will be for R2 plus R3, and it will be 0, 0, 688 over 45. Next, negative 196 over 45, and negative 121 over 5. Okay, next step, still the same thing. We need to remove the value under the leading one. So the next step is 2R2 plus R4. It will be 0, 0, negative 196 over 45, 592 over 45 and 9. The next one is we need to search for leading one for R3, so it will be 45 over 688 R3, and so it will be 0 0 1 negative 45 negative 49 over 172 and negative 1089 over 688. Okay, next we do the same thing, which is we remove the value under the leading one, and will be 196 over 45 R3 plus R4, so it will be 0 0 0 1537 over 129 and 259 over 172. And the last one, we need to find the last leading one, which is row 4 column 4, so it will be 129 over 1537 R4, so it will be 0 0 0 1 and 777 over 6148, and we will get the REM form. Okay, next step, which is step 5. After we get the REM form, which is row element echelon metric form, we need to convert the REM to system of linear equation back. So it will be I3 minus I1 minus 1 over 4 I2 minus 1 over 3 I4 equals to negative 9 over 8. For second equation will be I2 minus 8 over 45, I3 minus 4 over 45, I4 equal to negative 3 over 10. And third equation will be I3 minus 45 over 172 I4 equals to negative 1089 over 688. And the last equation will be I4 equal to 777 over 6148.
So the next step, we will use the batch substitution. For the simplify, the batch substitution is the process of solving a linear system of equations that has been transformed into row echelon form, which is REM, or reduced row echelon form. The last equation is solved first, and the next to last, and so on. Alright. So for this question, we already get our REM or our REM. So we just substitute it, which is I4 equal to 777 over 6148, which is we get 0.12648. For the I3 will minus with the 49 over 172, multiply with the I4, we will get firstly, which is 0.1264 equal to negative 1089 over 688, and we will get I3 equal to negative 1.5468. For the I2, we'll minus with 8 over 45, multiply with the I3, which is negative 1.546a, minus with the 4 over 45, multiply with the I4, 0.1264, equal to negative 3 over 10, and we will get the I2 equal to negative 0.5638a. Lastly, for the I1, we minus with the 1 over 4 I2 and minus 1 over 3 I4 equal to negative 9 over 8. We just substitute the I2 and the I4 in the equation, which is we will get I1 equal to negative 1.2238a. So for the final value for the I1, I2, I3 and I4, for the I1 equal to negative 1.2238a, For the I2 equal to negative 0.5638A. For the I3 negative 1.5468A. And I4 0.1264A. So what the conclusion we will get from our study is there are many real life application of linear algebra. There are plenty of them that we can study. So from our study, we get about the electrical flow, which is using the Kirchhoff law. So we have found out that the value of current in the circuit by implemented by the Kirchhoff law. We have learned how to use the Gaussian elimination method, which is the GEM, to help us solve the daily life problem. The model for the current flow is linear because Kirchhoff law is linear, which is the voltage drop across the resistor proportional to the current flow through it. So no wonder linear algebra is versatile to use in many daily life application. So that's all from us. Thank you. Yeah.